What's going on, guys? Mr. Garcia here, Mr. Michael, whatever you call me. Today, we're talking about composition of functions. So, you may have covered this already in Algebra 2. So, it's a great little refresher, a little reminder. The first little terribly witty but terrible subtitle is composing music is fun. Get it? Because composition and fun functions. Okay, cool. So next part here is, hey, let's just start off simple here. Let's evaluate this function at your desired domain value. So if you want to write this down, you can. You don't have to because it's a pretty simple one. Because if we have f of x equals 3x minus 7, to find f of 5. So say it out loud right there. Give you a second. 3, 2, 1. You're correct. It's you just plug in the value of 5 for every x value in our equation. So we had f of x equals 3x minus 7. To find f of 5, you replace every single x with a 5. So in this case, we have 3 times 5 minus 7. So surprise, 15 minus 7, which is also equal to 8. So this is just simple function notation. So what is a composition of functions? A composition of functions is given multiple functions, as in more than two, as in two or more, we can compose them. So we can put them together. So in this very blurry picture, you see that I'm taking some input, which is x in this case, and I am plugging it into this g of function. And after I plug that in, I get out a g of x function. There's a laser pointer, is there? Yeah, there is. Cool. So take this x, plug it into my g, and I get out a g of x function. And then from that g of x, I'm going to plug that into f and get out another output of f of g of x. So it can be viewed as x goes into g, and then the output from g, which is g of x, goes into the input as f. So let's just get down to it. So what is some notation for this? You may have seen this, you may have recognized this, but we have, is he here? Dude, okay. I didn't think he would get here on time. So we have a special guest for you guys, and he's going to kind of introduce what does it mean to compose two functions together. What is composition of functions? Let's look at this notation from our very special guest. Let's throw it to him.
Get this over with. 1, 2, 3, 4.
The winner takes all. It's the thrill of one more kill. The last one to fall will never sacrifice his will. Hey, I didn't see you there. Hi, my name is my name is Justin Woodpond, and I was just kind of cool. So, hey, I was called in by Mr. Garcia. He's a very, very, very cool, good, near friend of mine. We composed a lot of music back in the day. You may know some of my classic songs like "It's Gonna Be May." He came up with that actually, Mr. Garcia. So props to that. And that one song of mine, "It's Like in a Mirror." Oh, that little that's actually Mr. Garcia as well. So I called it. He called in a favor. He told me, guys, we're composing. Turns out you're not composing music. Who figured, right? I thought you would be doing that in math class. But it turns out I'm also skilled in mathematics, the mathematics of art. But it is what it is, right? So I just thank you. So I just have to have this whiteboard here of just different notations. So the first notation for composition of functions, you may see it as f, the little dot there, g of x. That little dot means composition. Composition. So that is also read as f of g of x. And these are the same things. No, it's not fog like I use at all my concerts because the fans just love me. So fog, f of g of x. Again, f of g of x is how you say that. The next one we may have is g of f of x. Again, that's pronounced as g of f of x Goff, like Jared Goff, because I'm famous in Hollywood. And so, Mitch Garcia just wanted me to pass along this message to you guys. So if you excuse me, I gotta finish the song. Where's the prompter? Come on, guys. I don't know these lyrics. In the sweet, sweet, sweet victory. It's all for the taking. It's all for the fight. In the sweet, sweet, sweet victory. Yeah.
Again, thank you so much, dude. I really do appreciate it. Yeah. Guys, that was Justin Timberwood. I'm sorry, Justin Woodpond. Um, I didn't think he'd come in. He came in at the last second. I was scared. I didn't think his plan would arrive in time. Just in your house, give him a little round of applause, just round of applause, keep going, and stop. So if you can hit him up on Instagram, you can follow him at any special music listening places you go to. I use Spotify personally, but hit him up on Instagram, man. He'll love to hear from you. Especially hit him up on Instagram. Is he gone? He's gone. Hit him up on Instagram. Tell him to pay off my student loans. He's struggling to do that for some reason. He's got money. He just doesn't want to do it. Instagram, hit his DMs for me. Okay, so notation. Different notations will be used for composition. So that first one that Justin helped introduce for us was, you'll probably see this a lot. Well, you'll see these two a lot. F of G. That little dot right there, that just means composition. So F of G of X, these two things are the same thing. You may hear teachers be like, oh, this is fog and this is golf. It looks like an O, that's why. But that means, well, you'll see what that means in a second. So here's an important thing. F and G are just some functions. If we want to, we can use H and J or K and L. It doesn't really matter the letter. It's just the process notation that matters. So again, F, composition of G of X, that means F of G of X. Those parentheses, you say as of. F of G of X. Same thing from the last one. G of F of X. That is G of F of X. So some practical, get some examples. So let F of X equal 3x minus 7, and let G of X equals 2x plus 5. So we're going to find the following. F of G of 5, and then G of F of 2. So if you haven't already, go ahead and start copying this down. And let's look at the first example together. So we're going to change that A. Instead of saying F composition G of 5, let's rewrite it as F of G of 5. All right? So whenever we deal with composition functions, always start on the inside. So I'm going to start off with G of 5. And again, we just saw this in the beginning of, hey, G of 5. You just plug in 5 for your value of X. In this case, we do 2 times 5, and then 10 plus 5, which is 15. So again, let me get my laser pointer. We first did F of G of 5, and we said, hey, we're going to start on the inside. And my inside was G of 5. And what is G of 5? Well, G of 5 is 15. And now here's the part that kind of messes people up. F of G of 5. We started on the inside, but we found that G of 5 is now the same as 15. One more time. G of 5 is now the same. It's equal to 15. So we took the output from our G of X equation, G of 5, and now we're going to plug that in to F. So we now are trying to find out what is F of 15. Well, to find F of 15, we do the same thing. We plug in 15 for X. So we'll do 3 times 15, and then subtract 7, so that's 45 minus 7, which will give us, 38. And just so we're clear, F of G of 5 equals 38. Again, the whole thing here, and I've noticed this part right here tends to mess people up. So the two things that tend to mess people up, they forget to start on the inside, and they forget about this switch here. So first, go ahead and write it as f of g of 5, and then start on your inside. You always start on the inside. In this case, we have 2. If we have 4, 5, 6, however many, you always start on the inside and work your way out. Inside, work your way out. So g of 5 is 2 times 5 plus 5. We saw that was 15. And then we plugged in that 15 into our f equation. Now, try b by yourself. So pause the video, and then we will see what the answer is. So pause it. Thank you so much for pausing. You guys are so kind. So g of f of 2. First step, write it as g of f of 2. Go ahead and get rid of this and do some parentheses. Now, where do we start? Go ahead and say it out loud. We start on the inside. We start on the inside. So let's figure out what is f of 2 first. So to figure out what is f of 2, plug in 2 for f. And we get now that, oh yikes, cool, f of 2 is just what, 6 minus 7, which is negative 1. And then here, this next value, remember, we said g of f of 2 can now be g of negative 1. F of 2 and negative 1 are now the same. So with this here, to find g of negative 1, I'm going to plug in negative 1 to every place I see an x. So that will be 2 times negative 1, which is negative 2, and then negative 2 plus 5, which is 3. So therefore, g of f of 2 is 3. Again, I'll keep repeating this. The thing people mess up the most I've seen is this step right here. Do not forget to plug in your negative 1 and then continue working from there. So if I had another number, another function outside of this g, I would then plug in 3. Okay, so let's keep going with another example. Oop, perfect. So try this by yourself. And f of x, a little bit bigger, 3x squared minus 5x plus 7. And g of x is 2x minus 14. We want to find the value of f of g of 6. Thank you for pausing the video. F of g of 6, I want to rewrite that as f of g of 6. And then I need to do g of 6 first. All right, that's what I need to do first. So when doing g of 6, you plug in 6 for every single x you see in your g of x equation. We only have one in this case, so g of 6 is 2 times 6 minus 14. 12 minus 14, which is negative 2. Now, next step, we take that negative 2, and we're going to find f of negative 2. And this part here, oh, my bad, cool. F of negative 2, so 3 parentheses negative 2 squared minus 5 negative 2. So we're plugging in twice here. Nothing too crazy. If you're using a graphing calculator, please, 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 please don't mess this part up. In your calculator, do not do this. Negative 2 squared. That's wrong. If you plug that in, you will get negative 4. However, think about it. What does that square notation mean? That square notation, it means you multiply that number that many, 2 times in this case, or that many times. Negative 2 times negative 2 should be a positive 4. But if you plug it in like this in the calculator, you're getting negative 4. The calculator takes the rules of PEMDAS literally. You must include those parentheses in your calculator. If you don't, you will get that wrong. I will probably, just to push your buttons, make a question like this on a post test and make an answer such that if you follow this top rule, you will get that answer and that will be incorrect. So here we know that negative 2 squared, we know that should be 4. Okay, so going back to our example here, yes, I'm not sure why I wrote that twice, totally fine. We know that negative 2 is 4. Negative 2 squared is 4. So then 3 times 4 is 12. Negative 5 times negative 2 would be a positive 10. And that gets us that f of negative 2 is 29. And make sure to box up your final answer quite nicely. F of g of 6 is 29. I'm not too picky. Notice here I said f of g of 6, and the question was in this notation. It's the same. If your teacher tells you to write it in that notation up there, let me do what they say. Let's see here. Cool. So to kind of wrap up this lesson, what if we have this? F of x is 3x squared minus 5x plus 4, and g of x is 2x minus 3. Okay, so everything seems pretty good now. How do we find the value of f of g of x? So early on the last one, what we did is, hey, find f of g of 6. We had a number, but we got only x in this case. Don't worry. Next lesson is all about this, but if you feel like you know, try this one out by yourself. Pause the video and try to do this one by yourself. It's okay to mess up. I want you to mess up. It's okay to be wrong. It's not okay to not try. All right. So here, pause the video. Welcome back. F of g of x. Well, let's do the first thing like we always do. Let's change that notation to the notation we like. So f of g of x. Okay. Nothing changes there. But we have an x instead of a number. Here's the thing. We still do the same thing. So in this case, we need to find g of x. Found it. So here we're saying, hey, g of x is 2x minus 3. I'm not changing g of x. I mean, because it just says, hey, take g of x. Boom, got it. And now I need to find f of g of x. So you may be thinking, wait, does that mean I need to? To find f of g of x, that means in your f of x equation, you're going to plug in every place you see an x, you replace that with g of x. So in the equation 3x squared minus 5x plus 4, I'm going to do 3, and let's get our red here. Replace that first x with g of x, which is 2x minus 3. Minus 5. Oh, I see another x. That means I must plug in g of x as well. Cool. So yes, it does look kind of messy, but we're not even done yet too. So when multiplying these out, another famous do not, we'll take that first part, 2x minus 3 squared. Do not do this. Do not be like, oh, 3 in front of parentheses. Clearly that means you distribute the 3. So you're saying, oh, that's what, 6x minus 9, and then square that. Okay, cool. No, do not do that. Don't do it. Don't. That's wrong. I will actually work it out over here to the side. So I'll work it out different color. 3 and then 2x minus 3 squared. What I'm going to do first is I'm going to take care of that 2x minus 3 squared. Remember, the squared denotes you multiplying that thing twice. Now, you have an option here. You can either do one of two things. You can either, let me get laser pointer, take this 3 and distribute it only to the first term and then multiply your two binomials. Or you can multiply your two binomials and then distribute 3. It doesn't matter. That's up to you. I think I see that people prefer to multiply these two and then distribute the 3. Again, doesn't matter. That's all up to you. Just don't do this. If you do this, this is one of the worst mistakes you can make in math. let's say you, for some reason, get to that 2x minus 3, and you're like, you know what? I don't want to listen to what Mr. Garcia is saying. I'm going to distribute this square. I wrote it way near to the top. And I'm going to distribute it to every part in there. So I'm going to say that is 2x squared minus 3 squared. If you don't want me to ball up and get in a corner and just cry my eyes out, uh, don't do that. And if you do want to see that, you're terrible. But no, you can't distribute the square. That would end up being 4x squared plus 9. So you'll see why we can't do this in a bit, okay? Going back to our original example down here. So I'm going to multiply 2x minus 3 times 2x minus 3. This is just a distributive property. You may have learned this as FOIL. You may have learned this as Punnett square, but it's really just a distributive property, okay? So here, 2x minus 3, I will multiply the first two terms. So 2x times 2x is 4x squared. And then 2x times negative 3 is going to be negative 6x. Negative 3 times 2x is negative 6x. And then negative 3 times negative 3 is positive 9. And now here, go ahead and combine your inside terms and then distribute the 3. Now, biggest thing here is, hey, notice I have a negative 12x. That is missing from up here. So if you distribute the 2 or the square to every term, you are missing a middle term. So you're missing part of your answer, but my bad. Here, that'll be 3. 3 times 4x squared is just, oh my bad. Let me just go ahead and do this. That'll be 12x squared. 3 times negative 12x is negative 36x. And then 3 times 9 is 27. So going back to here, we now have for this first part, all that first part is now 12x squared minus 36x plus 27. That was just for those first term. Now for this second part over here, it's not too crazy. Distribute the negative 5. Be careful, that's negative 5. So negative 5 times 2x is a negative 10x. Negative 5 times negative 3 is a positive 15. Then you add a 4. And then finally here, we're going to combine our like terms. So we got an x here to combine. And then we got just some, oh, my bad. Let me go back. We got just some numbers here to combine as well. And let me get a different color. Pen. Perfect. So here, notice we don't have any x squares. Totally fine. 12 is just going to hold down the fort. Negative 36 minus 10 would be negative 46. You're close. 27 plus 15 plus 4. If it helps, do 27 plus 19. For some reason, I'm blanking on that, but that'll be 27 plus 19 is 46. You're about to see me live on camera. Mr. Garcia doubting himself. No, 46. I was right. Cool. So that means here we get this nice little 12x squared minus 46x plus 46. Yes, this is possible. Next lesson, we'll discuss this more in depth.